Number one, the U.S. Department of Agriculture and its Office of Food Official Food Plan states that the average cost of food for a 14 to 18-year-old male is $261.50 per month. Assume that the monthly food cost for a 14 to 18-year-old male is approximately normally distributed. There's that key phrase there. With a mean of 261.50 and a standard deviation of 1625. Find the probability to the nearest 10,000th, which means 4 places, that the monthly food cost for a randomly selected 14 to 18-year-old male is, well, the first one is less than $280. So I know it's normally distributed. The mean goes in the center, 261.50. And I want to know less than 280. Well, 280 is bigger than that. And less than that means shade to the left. So I need to find a z-score for 280. My z-score is 280 minus the mean. How far away is it from the mean? Divided by the standard deviation, because that's what z-scores are. Z-scores tell us how many standard deviations away from the mean our piece of data is. So in this case, we need to do 280 minus 261.50 divided by 1625, which gives you a z-score of approximately 1.138. So that 280 really doesn't matter anymore. I'm now going to work with that z-score. And I want to know what's the probability that my z-score is less than 1.138. So I'm going to go to my TI-84, hit second distribution, always pick normal CDF. My lower bound, well, if I look at my picture there, I don't really have a lower bound, I go on forever. So I need to type in a really, really negative number. Negative 1, 0, 0, 0, 0, 0, 0, a bunch of zeros there. My upper bound, well, where do I want to stop? I want to stop at that z-score of 1.138. And when I hit enter, I have a probability to go into 4 decimal places of 0.8724. So that probability is 0.8724. That's my answer for that question. More than $270, so I'm going to make my normal distribution. 261.50 goes in the middle. More than 270, well, 270 is that red line there. More than that means shade up. So I get my z-score, 270 minus the mean. Well, that's how far away I am from the mean, but I want to know how many standard deviations away I am from the mean, so I'm going to divide by a standard deviation. That's how I compute a z-score. 270 minus 261.50 divided by 1625 gives me a z-score of approximately 0.523. So that region that I shaded there is the probability that my z-score is bigger than 0.523. That's the probability that I want to figure out. What proportion of adult males, of 14 to 18-year-old males, is bigger than 270? 270 is irrelevant now. I now have that z-score to work with, 0.523. So I'm going to go to my normal CDF. My lower bound this time, we'll look at your picture. How low do I want to add up to? 270 is as low as I want to go. But I'm not going to type in 270. I'm going to type in a z-score of 0.523. And then since there was no stopping point, it went on forever. I'm going to type in a really, really, really large number, like that one there. And this will tell me that probability. That probability to 4 places is 0.3005. 0.3005. More than $250. More than $250. So I'm going to draw my normal curve. My mean goes in the middle. I want 250. 250 is smaller than the mean. 250 is all the way over there. I want more than 250, so I'm going to shade up. So I should be expecting a number bigger than 50%. because that's what the mean splits it in half there. So I should be expecting a number bigger than 250. Well, let's find my z-score. My z-score is 250 minus the mean over the standard deviation. I'm expecting a negative z-score here. Why am I expecting a negative z-score is because that 250 is smaller than the mean. So when I find my z-score here, 250 minus 261.5 divided by 1625, I get a z-score of approximately negative 0.708. So I want to find the probability that my z-score is bigger than negative 0.708. Go to my calculator, second distributions, normal CDF. My lower bound this time, as low as I go, is that 250, but I can't type in 250. I can only type in z-scores. So negative 0.708, comma, a really big number. And when I hit enter, there is my probability, 0.7605. That number is bigger than 50% as I expected because I have more than half of that distribution there. And finally, between 240 and 275. So the mean goes in the middle of 261.50. 240 is less than the mean. 275 is bigger than the mean. And I want to know what's the probability I pick someone between there. So I'm shading that middle region there. So I actually need to find two z-scores here. I need to find the z-score for 240 and for 275. So my z-score is 240 minus 261.50 over 16.25. 240 minus 261.50 divided by 16.25. 240 is 1.323 standard deviations below the mean. That's what that negative means. It's 1.323 standard deviations below the mean. And then my second z-score is 275 minus 261.50 over 1625. 275 minus 261.50 over 1625. That dollar amount, 275, is 0.831 standard deviations above the mean, because it's positive. So what we're finding here is we're finding the probability that my z-score is trapped between negative 1.323 and 0.831. My lower bound is that 240, which corresponds to a z-score of negative 1.323, and 275 corresponds to a z-score of 0.831. So when I go do second distributions, normal CDF, my lower bound is negative 1.323. Negative 1.323. And my upper bound is 0.831. 0.831. We'll try that again. 0.831. There we go. And paste. Or I'll paste it twice, and that probability is 0.7041. 0.7041. Make sure you're rounding correctly. Don't lose silly points because you rounded incorrectly. Number 2 is a continuation of this here. So that USDA document also states that the average food cost for a 14 to 18-year-old female is $215.20 per month. Assume that the monthly food cost for a 14 to 18-year-old female is approximately normally distributed with a mean of 250.20 and a standard deviation of 1485. What would be the monthly cost for a female with the same z-score as a male with a monthly cost of 250? So we have two different distributions going on here. We have our male distribution from the last problem, which was centered at 261.50, And then over here we have our female distribution, which is centered at 215.20. And I want to know what's the female that has the same z-score as a male at 250. So a male at 250 is over here. And we already calculated that z-score, didn't we? That has a z-score of negative 0.708. So I want to know what female over here corresponds to that same z-score. So I'm going to call that my x and say x minus 215.20 over my standard deviation for females is 1485. I want to know when it has that z-score. I want to know what female dollar amount is negative 0.708 standard deviations away from the mean. To solve this, I'm going to multiply both sides by 1485. So negative 0.708 times 14.85 gives me negative 10.5138 equals x minus 215.20. Then I'm going to clearly add over that 215.20 and get 225. So I'm dealing with money here. I'm going to round to 71. So a female that eats $225.71 a month is really the same as a male who eats $250 a month. Number 3, the distribution of monthly rent for a one-bedroom apartment in a city is approximately normal with a mean of $936 and a standard deviation of 61. So I have a normal distribution here. 936 goes in the middle, and there's my standard deviation. A graduate student is looking for a one-bedroom apartment and wants to pay no more than $800 in rent. Well, here's 800 below the mean. Of the following, which is the best estimate for the percent of one-bedroom apartments in the city with a monthly rent of at most 800? I don't want to be bigger than 800, I want to be smaller than 800. So I'm shading that way. Well, 800 is hard to work with, I need my z-score. So when I find my z-score, I'm going to do 800 minus 936 divided by 61 to get a z-score of approximately negative 2.23 about. So I wanted to find the probability that z is less than, look at your shading here, less than, not 800, negative 2.23. We can only work with z-scores when we use normal CDF. So I'm going to clear that all out because that's crazy. Second distributions, normal CDF. My lower bound, look at your picture, that goes on forever. So my lower bound is going to be a really, really, really negative number. Negative 1, 0, 0, 0, 0, 0, 0, 0. My upper bound, I'm just going to keep adding zeros there apparently. My upper bound is my z-score of negative 2.23. Paste. And I get 0.0129, 0.0129-ish, which corresponds to about 1.29%. So I'm going with choice 1 here. That shaded region is 1.3% of that normal curve. Clearly my picture is not drawn to scale here. Number 4, the commuting time for a student to travel from home to a college campus is normally distributed with a mean of 30 minutes and a standard deviation of 5 minutes. If the student leaves home at 8:25, what's the probability that the student will arrive at the college campus later than 9 a.m.? So I know I have a normal distribution here with a mean of 30 minutes. I'm measuring the travel time here. So if they left home at 8:25 and got there at 9, that's 35 minutes of travel. Because this distribution, that mean is 30 minutes of travel. So 35 is here. And we're lucky, we don't even need to really think about a z-score because the standard deviation is 5, so that's one standard deviation away from the mean. So my z equals 1. You could have done 35 minus 30 over 5, But if you actually thought about what a z-score was, it's how many standard deviations away from the mean you are. It's a little bit easier, actually. So you have a z-score of 1, and I want to know what's the probability that they'll arrive later than 9 a.m., which means it took them more than 35 minutes to travel there. What's the probability that z is bigger than 1? What's the probability that z is bigger than 1? Well, let me do second distribution, normal CDF. My lower bound is 1. My upper bound is it goes on forever. And paste. About 15.87%. 15.87%, which leads me to believe my choice is 16.116. The tricky part here was dealing with the time. We're measuring how long they spend traveling. So if arrive after 9 a.m., that's going to be after 35. Number 5. A grocery store purchases melons from two distributors J and K. Distributor J provides melons from organic farms. The distribution of diameters of the melons from J is approximately normal with a mean of 133 millimeters and a standard deviation of 5. For a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137? So we have a normal distribution for J here. 133. I want to know bigger than 137. Greater than 137 means I'm shading that way. So my z-score is 137 minus 133 over my standard deviation of 5. 4/5 is 0.8. So what's the probability that z is bigger than 0.8? I'm just going to go up and steal that one I just typed in and make that 1 a 0.8. 0.8, comma 1000. About 21 point. Let's see what they asked us to round to, if they did. Nope, just what is the probability? So we'll say it is. We'll go 3 decimal places. 0.212. About 21.2%. Melons from distributor K are also normally distributed. So we also have, that's a terrible normal distribution there, but that's okay. With a mean of 140, this is K here, and a standard deviation of 6, determine the weight of a melon from distributor K that corresponds to a melon with a weight of 137 from J. So there's that same, I want to know what's that same point down here. I want to know what's that 137 correspond to down here. Well, it had a z-score of 0.8. When I compare normal distributions, we have to go and work with z-scores. So let's call that x. X minus 140 over a standard deviation of 6 should equal 0.8. I'm going to multiply here and get 4.8 equals x minus 140. Add over 140 and get 144.8 is that melon. So a corresponding z-score of 137 for distribution J is 144.8 for distribution K.